Hello and welcome back to another episode of Math with Stone. Today we are going to be figuring out counting and probability at the same time, but focusing on symbols such as and or, and how they affect probability problems. So this first one we got a fair dice. The event of rolling an even number would be event A, and the event of it being for event B is it must be greater than 4. So the numbers that are even are of course 2, 4, and 6. But if it has to be greater than 4 for event B, that would be 5 and 6. This A upside down U, B is the intersection between A and B, which means it's what they have in common. It also means and for probability. So in order for these two things must both happen, that only is the one number, which is 6, but the answer to this question would be find the amount of this would be 1 out of the 6 times if it were a probability, but there is only one thing that allowed that to happen, and that would be if the number was a 6. Okay? So if fair dice is rolled once, let A be the number of an even number, so still 2, 4, and 6, and B be an odd number. Are those ever going to intersect? Can you ever have 2, 4, and 6 overlap with 3, 5, and 1? I forgot 1. And the answer is no. So this is often called the empty set because it doesn't exist. All right? Moving right along, it's going to get into probability pretty quickly here. So A is is landing on a 4 or a 10. So 4 or a 10, so we can write that there, 4 and 10. B is if it is divisible by 4. So if we look at all these numbers, things that are divisible by 4 would be 4, 8, and 12. And A and B would be when they both happen, and that happens at 4 and 4 only. So we would have the number 4 there. There are two ways that I should have addressed number 1 and number 1 only, because this one was the empty set. There is two ways that you can do it. The number of A and B is 1. The actual event of A and B would be the thing that we got, which was 6. Okay? Normally we care about the 1 for probability, and the 6 is what you're doing in your head. That number 6 is the one time it occurs. So let's continue on. Let's say now we're dealing with probability. A card is selected from a standard deck of cards. What is the probability that that card is a diamond and is a 7? So there's two ways to view it. You could first figure out what is the probability that it would be a diamond. Well, 1/4 of the cards are diamonds, and 1/4 of them are 7s. This would be a very common mistake, though, because if you think about it, out of these diamonds, one of them is a 7. You can't utilize that twice. So this 1 out of 4 times 1 out of 4 will get you close, but it actually won't be what you need it to be. And if it said or is a 7, this problem would be a little bit easier. But it says and. So how many of the cards are there in a standard deck of cards? Standard deck of cards has 52 cards. We are only looking for the 7 of diamonds. So we have a 1 out of 52 chance of that occurring. That's pretty low. That's actually very low. And I think I also realized that there are way more 7s than I think about. There are 4 out of 52 that are 7s. And if we did that, we would get close, but it really wouldn't be fully there, I don't believe. A card selected from a standard deck of cards, what is the probability that the card has a number that is divisible by 2 and is black? Okay, so now we're getting somewhere. How many of them are divisible by 2? Well, divisible by 2 would be half. Half are divisible by 2. Well, how many of them are black? Also, half of the cards are darker cards, so we would have 1 out of 2 times 1 out of 2, which is 1 out of 4. All right, moving right along. Let's see what we want to do next. Let's do this one right here, number 7, because it has a U. U is different. U is not looking for the overlap. It means or. Or problems are much, much different. So let A be the event spinner lands on a vowel. Well, the vowels are A, E, U, and O. So A, E, U, and O, which is the number of those possibilities 4. And B would be the event that it lands on the letter J. So that would just be J. Again, we're not doing probability here. We're just looking for what are the letters. Now, you also could make the argument, see how the A repeats, that you could put 2 A's there. And that is definitely something that could happen. And you could make the argument that we should put 2 J's there. And that would indicate that there is a little bit of a higher chance that J would happen because there are 2 of them. What are the possible outcomes of each event? Well, we did that. A or B would be all of these put together. The A, the E, the U, the O, the J, and the J. Again, if you're listing them out, that tells you that the number of times that A united with B would be 1, 2, 3, 4, 5, 6, 7. And if you wanted to find the probability of A united with B or A or B occurring, that would be 7 correct answers out of the total, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have a 7 out of 10 chance of the event of it being a vowel or being the letter J. Let's do another probability. Here we go. What is the probability of drawing a card from a standard deck and not getting a spade? The not getting a spade implies that you can do one of 2 things. You can either find the probability of getting a spade and subtract it from 1, or you could find the probability of just not getting a spade. Well, that would be, you could get a club. This would be clubs. You could get a diamond. Or you could get clubs, diamonds, hearts. And you have a 1 out of 4 chance of getting a club. You have a 1 out of 4 chance of getting a diamond. You have a 1 out of 4 chance of getting a heart. If you add all 3 of these together, you get a 3/4 of the idea of not getting a spade, because 3 out of the other possibilities are not spade. But you could also think of it as, well, there's only a 1 out of 4 chance that you would get a spade, so there's a 3 out of 4 chance that you would not be getting a spade. What is the probability of flipping a coin and not landing on tails? Well, landing on tails happens half of the time, so not landing on tails would happen half of the time as well. Carmela purchased 10 raffle tickets. If 150 were sold, what is the probability that 1 of Carmela's tickets will not be drawn? This is a better problem, way better problem. So, what is the probability that 1 of the tickets will not be Carmela's? So, I like the opposite of this, but we'll get to that. If we want to figure out that hers are not going to be drawn, well, that would be 240 of them out of 250 are not hers. So that would just be a 24 out of 25 chance that they are not going to have her win. Now, if they drew like 5 tickets, that would be a different story. The probability of her losing 5 times in a row is going to be in a different video. But if we wanted her to lose 5 times in a row, it would be 240 out of 250. But then we needed her to lose again. That'd be 239 out of 249, because 1 of them would have drawn. And then we would need to lose her again, 238 out of 248, and so on and so forth. 237 out of 247. It would keep going for every time we wanted her to lose, and that would be the chances of her not winning, which indicates that you could also figure out the probability of her winning. Because if she loses this many times, that would be losing, 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 losing. She would win the opposite of that. So here, she has a 24 out of 25 chance of losing if they only draw 1 card. But if they only draw 1 card, she does have a 1 out of 25 chance of winning. One more. What is the probability of a spinner not landing on a 5? Well, how many of them are not 5s? 5 out of 6. There's only 6 numbers on this little spinner thing. They could have just said a dice. The chance of it landing on a 5 is 1 out of 6. The chance of it not landing on a 5 is 5 out of 6. Okay? That's going to do it for this one. Stay tuned. There is a lot more probability. All probability just takes practice and a little bit more and a little bit more practice, and you get pretty good at it. All right? I will see y'all then. Bye.